My opportunity today is to talk to you about the various enhancements to RecurDyn Professional and ProcessNet with RecurDyn V9R3. And okay, so first one, there's been a variety of enhancements to the graphical user interface, and actually we rely upon your feedback to give us ideas. And you know, since we have users around the world, you know, we're getting good feedback from many places, and so then we try to apply it. So the first one is input shortcut for the modeling option. And so, as you know, when you give a command in the graphical user interface, then there might be, there's this pull-down menu that gives various methods for creating the object. So in other words, one example is if you're creating a joint, you can create a joint by clicking at a single location, and then RecurDyn will try to infer all the other inputs. Or you can put in, you know, pick different bodies and different locations and so forth. There's many options. So now, if you hit Tab plus Spacebar, then that gets you over to that command toolbar. So the tab is going to bring you to this different input options, and then with the spacebar you go into the input field where you can then input a precise value. So if you're going to, for example, create some kind of let's say a piece of geometry, a sphere, and it wants a radius, then you just hit the tab and the spacebar, and then you can get to input field, and then just type in that radius or copy and paste it from a spreadsheet or wherever you have the data. Okay, so that's all related to that command toolbar. So the next one is, I think, been requested by many people for a bit of time, and that is, you know, on a lot of the CAD systems, when you zoomed, you could, you know, pick a reference point, and then it would kind of zoom in towards that point. And so now, if you hit the Control key, and then you can use the wheel on your mouse. Then with that, then you're able to select a reference point. So I think this is a pretty welcome upgrade to add this enhancement. This next one I think is another great one. So there's this new icon in the view control bar and in the working plane toolbar. And you can either view at a plane or change to a plane. And the idea here is this is an arbitrary plane, and that arbitrary plane is selected by using any of the planes that are available for each marker in the model. So if you have something that's oriented in some very strange angle, you can just use any marker on that body or on that joint or whatever, and then you can do this view at plane. When you click that, then you can just come and move around by the marker, and it will highlight the different planes. Once you have what you want, you just click it, and then the viewing plane is then changed. So then also with the rotational control in the viewing screen, this again has been a long time requested thing to, I mean, we've had this ability to define a center point, but it was a separate operation. So now you can pick a center point for your rotation, you know, as you are, you know, doing the rotation operation. So the idea is the shortcut key is the Y, letter Y. And then, so you click that or press on that key, and then the cursor is ready for you to navigate to the center point of interest for the rotation. So you navigate to the point, and then when it's highlighted, then you click on the left mouse button, and then you then hold down the left mouse button. I mean, so in other words, you click down, you pick the point, and then you hold that left key down, and then as you move the mouse, then it's rotating about the point you've selected. So this makes it easy to go and rotate around a given point quickly without this separate command needed. So I think these enhancements of these last two slides here are going to be really helpful for working more efficiently in the working window, graphics window in RecurDyn. One of the things that sometimes has been, almost irritating is that as you're changing modes in RecurDyn, and you would come back to where you were, then things would be reset in a way that wasn't what was wanted. So the database window now has some added intelligence that when you go from like a main level down into a subsystem, or into the body edit mode for that matter, and then you come back up, then you're in the very same location that you left in the database window. So this isn't maybe a huge thing, but I think it's a very helpful and convenient thing. By having things be the same way as when you left them, for me, it's like having the database window reset, as a distraction and kind of, would break my concentration sometimes. So really happy to see this enhancement. As you know, a few releases back, RecurDyn introduced this relation map. And so the idea is that you could pick a component in the model, and then this map would come up and it would show everything that was, connected to the entity that you had selected. So in this case, like on the left, with the V9R3 view, we can see that we pick a body, and then we can see, there's a couple joints between that body and another body, and then there's also one contact between that body and another body. So then this would be displayed, and then you could work with that. So now with the V9R3, you still have that capability, but now the icons, instead of just having circles for everything, now we have the very same icons that are appearing in the database window are now also used for the relation map. And I think that's really helpful because, we don't like to have to learn many things, and also we don't like things depicted in different ways when they're actually the same thing. So now with this enhancement in V9R3, then these icons will look very familiar to us, and then we'll be able to interact with things in a better way. So let's see. Oh, and then the other thing that you can do is when any of these entities that occur in the relation map, you can select that entity, right mouse click, and pop up the property dialog box for that entity without having to go back to the database window. So that's anytime we can get rid of extra steps, that's a good thing. Okay, this next one, I don't know how many people are doing the DOE in RecurDyn, but in RecurDyn Professional, in the base package, we have a basic DOE capability. There's a more advanced DOE capability as part of the auto design module that has some very sophisticated DOE planning tools and so forth. But in either case, when you're doing a DOE simulation, you plan a set of runs, and the problem has been is that sometimes when you're changing different parameter values, sometimes you end up in a situation, you end up posing a situation which actually is not valid. And then the simulation ends prematurely because it's not possible to continue the solution. Maybe a certain component is too long or something. So what's happened in the past is that the DOE process would stop part of the way through, and then you wouldn't get the other results, and that was not very good because sometimes people were leveraging the ability to set up the DOE and then have a number of runs occurring overnight. And so then you come in the next morning and see, okay, oh yeah, I was out of bounds or out of range with a certain thing, but then the other trials that maybe were valid were not run because it just would quit the whole process. So you can see now in the design study dialog box here on the left, on the bottom, there's a new section here which you can check on, which is when simulation fails, continue with the next DOE trial. And if there is a failure, set the PI, which is the performance index, it's the output, set, and you can have any number of performance indices. So, but all of them will be set to a value of -1 or whatever you put into this field here. So in the case of having information for optimization or whatever, a lot of times the technique used is that if the solution is invalid, then to help the optimizer know that, hey, that's a bad place to go, then if you're trying to minimize something, then you may set the value to kind of a high value compared to the other values. I mean, I wouldn't recommend setting it like super high, because then numerically you could have some issues. But just to have it be 3 or 4 times higher, say, than the other values, something like that. Or if you're trying to maximize something, then you could set it to be 3 or 4 times lower than the other values you're working with. But something to give feedback so that whether you're doing the response surface or the optimization, you're given some kind of feedback that that's an invalid location. Anyway, so you get to set what that is, and then when you run the simulation, it'll keep going. In this case, the model that was being worked with, it had a certain number of valid solutions, and then once you got to these last four cases, they were all invalid. But the point is, each one of them was run, and then you were able to find out that they were all invalid. It is possible that you have an invalid solution and maybe the next one is valid. So in that case, then you would have some reasonable number here and so forth. So I think this makes the DOE capability more useful, and a lot better knowing that if you're going to do overnight run or over the weekend set of runs, that it will keep going and do all the runs. Of course, if you run out of disk space or something like that, there's nothing we're going to do about that. But at least the process from the RecurDyn side will keep going. This is quite new. As you know, we're using the Parasolid graphics kernel in RecurDyn, and we have been for a very long time. And when we first started, we really couldn't access a lot of the capabilities of Parasolid. And as time goes on, we're given more and more access to it. So we still are assuming a process where people are importing geometry, whether it's from a Parasolid file, or we have the translators that can import directly the CAD files, and then we also have a step translator. So we're assuming people are mostly importing geometry, but if sometimes you want to do modifications, and so the ability to import geometry from CAD and then in RecurDyn be able to modify it can be very helpful. So you don't have to go back to CAD and have to do the modification there and then do the export from CAD, import to RecurDyn, and so forth. Our capability is quite robust that you can go ahead and add fillets and different things. And I've had cases where there was contact that was going around the corner of some geometry, but the way it was modeled, the corner was like perfectly sharp. And so when you have that kind of a 90-degree turn on a surface that's supposed to be a contact surface, it numerically is not well defined where you go past that corner. So then to put in a fillet so that you have this gradual change of angle it's a lot more reasonable, and the contact calculation works a lot better. So that's been available for some time, but then what used to be the case is that you'd build up some kind of, or you'd have built up maybe, well, in the case where you're creating your own geometry, you would have a collection of primitives, a collection of Boolean operations. And once you had that built up, if you wanted to make a change, you had to kind of delete and undo a lot of things, make the change, and then kind of redo the Boolean operations. But now we have this ability where you can actually go in and change the properties. And then the other thing, so you can see on this pop-up menu, there's a properties capability on this tree, which has now been added. So in other words, you have this subtract 6 is your piece of geometry that you've created, and now there's this new tab called Boolean, and that's where you have this tree structure shown, and then you can go into each area, look at the properties, but then you also have this swap capability. So if you pick swap, then you can actually bring in some of the basic child geometry. You can swap it with some other piece of geometry. So, so between these two capabilities, being able to modify things without having to redo everything, and to be able to swap in geometry without having to redo everything, this really makes it a lot more approachable to quickly, examine different design changes. And then in conjunction with all that, you can have parametric values as part of the basic pieces of geometry, which then means that you can have a parametric value actually morphing the geometry, which, we didn't have this capability to do it this way before. So this can be, I think, very powerful. So then thinking back to the DOE, you can set up a range of runs where you're actually morphing the geometry as well as other characteristics of the model like spring stiffnesses or whatnot. More enhancements on the solid modeling. So we have this ability to split a component, a solid, into two pieces. Nice. By using a surface. So you just define the surface and then reference that surface, and then you get the two different components. And then another capability that's new is this new region component. So basically, you may have, and actually with the particle works and the EDEM models, I mean, sometimes we're generating this place for the particles to go. So in this case, you can actually have a solid model, and then you just put that within a big block. You do the region operation, and then it will create it'll create a cavity in the block where it subtracts out everything, for that particular body, and then you can do some other operations on this block, but you can maybe you want to do this region operation and then do this new split operation, and then as you see, it's like you have half of a mold. So then if you want to then at that point say, okay, I want to use particle works to model injecting my fluid into my mold, you could do something like that, pretty quickly to set it up. Okay. So, over time, we've been adding more and more with regards to, looking at contacts more accurately, and in particular, looking at contact pressures. So as we can see in the animation here, we have a gear set, and the gear profile is not perfectly flat. So, we can see how we have this distributed contact pressure. And so this contact pressure is available with the various GeoContacts, GeoSurface, GeoSphere, GeoCylinder, and also with the gear toolkit, with the gear involute. And then there's also a contact UV surface to sphere, and we'll talk a little bit more about that here in a couple slides. UV just means it's a surface where you're specifying a U and a V parameter, which describes the density of the contact representation according to the values you get for U and V. So in order to set this up, if you look at the properties dialog for the geosurface contact, we have some new options here to be able to calculate pressure. and that's done, you can pick, one or both contact surfaces, and it all depends on, what's the right thing to do. Well, it depends on the contact situation and what those surfaces are shaped like. Sometimes to have both contact pressures being shown, it gets to be a little bit too confusing. So you may want to pick one or the other. It just depends upon the shape of things. Anyway, and then under the contour dialog box, then again you can pick which item, which contact to include, in the particular viewing of it. And then you'll get something like the animation shown here on the lower right. So this, I think, and this information can be very helpful to understand what's happening in the system, and also, for like the gear object, there are ways to modify the tooth profile, so then you can do modifications and compare the pressure distribution. Okay, so it seems like each release we're always getting more with the GeoContact. And so one of the contacts that we've had is this Geo Curve to Surface contact. And now there's a new field of information that you can set, which controls the thickness of the curve. So this is set with the curve segments, which is accessed in the properties dialog box for that GeoCurve surface contact. So the thickness is used so that even though the curve is like a one-dimensional topology, so it's just segment to segment to segment, like a string, by putting in that thickness, then you actually have a finite thickness with regards to the contacts. So then now you have something that is very much like a cable. So that can be very helpful. And this kind of capability has existed before when using the full flex curve, but now we have this capability when you have the little rigid segments on the curve. So now they can have a thickness. Okay, and then for the geosphere contact, we've added in this contact sphere option. And you've seen this before with some of the other contacts, but you can check on to synchronize with the geometry. And then if you have, if you're using a sphere to do this contact, if you modify the size of the sphere, then that modification then applies to this contact automatically. So again, if you're doing a design of experiments, doing many runs, you can just use a parameter to change the size of the sphere, and then the contact is already updated for you. So that's quite convenient. Okay, here's that UV surface to sphere contact. So as you can see here, in this middle left picture here, we have the axes showing the V direction, U direction for the sheet that the sphere is going to sit on. So in the lower left, we see what the result is if in the U direction we have a total of 20 segments, and then in the V direction we have a total of 5 segments, then we get something that looks like that. And then as we add, increase the U and V values, then we get the finer discretization of the contact surface, as you see there. So then when you're, so the contact itself looks just, very consistent with the other contacts. And then when you click on this contact geometry button, then you have the opportunity to change the number of patches in the U and V direction. And sometimes, with these other contacts, basically it's changing the resolution of the contact patches according to factors that you can control, other factors like that are related to curvature and so forth. So things like the plane tolerance factor is an example of that. In this case, even though there's a curve to this surface, what we want to do here is, as the ball rolls down it, we really want to have uniform discretization of the contact patches as we go through the extent of the surface. And so this UV control makes it very convenient to set it up like that. So that's our UV surface to sphere contact. So another new contact. Seems like we get a new contact with every release, and which just gives us more and more capability. Okay, next one here is a Campbell diagram. And this one, you know, Campbell diagrams are used a lot in certain areas, but they also, you know, have usages, you know, beyond the normal thing. But, you know, kind of the first place I ever saw a Campbell diagram used is with respect to looking at behavior of an engine. And so you'd sweep through a certain RPM, and then you would see certain frequencies, and so you wanted to plot that. So the Campbell diagram has existed for several RecurDyn releases. So it was there with V9R1, it was enhanced in V9R2, and now with V9R3, more enhancements to actually add a 3D version of it, which can be very helpful in visualizing what is going on. And you can see that, you know, the dialog box and then the ability to switch between the 2D and the 3D graph type, as I'm pointing to here under this Campbell diagram dialog box down here. So, you know, looking at the RPM versus frequency, RPM versus order, so you can have all these different things and the magnitude of the function all shown in the 3D Campbell diagram. So you get to choose, as you see in the dialog box, I mean, you know, here, you know, the typical things of RPM and frequency and whatnot, but you're choosing what function goes in there. And so then that opens it up for other applications outside of the engine realm. And we do have, I've seen the usage of this new 3D capability, you know, for other things. So, I mean, it is versatile, not just for engines. This is a new capability, I think, quite useful. Sometimes it's appropriate to run the simulation in pieces. And, you know, with the initial conditions file, you can run a simulation to a certain point, and then you can restart later on from where you were and just keep going. Well, then you've had two sets of outputs and, you know, separate animations and whatever. But now there's new capability that's built into the user interface to merge results files all together. And you can see we have the different results files. So the RPLT can be all merged together for the plotting, and then the RAN is the RecurDyn animation data. And you can even merge particle data from these co-simulations all together to get then one single run, and you know, as far as both animation and plotting. So pretty convenient. So this one I've asked about for quite a while, and you know, it's maybe these descriptions are still not perfect, but at least now we have in the help documentation, we have a list of error codes. And you know, there's already been some improvement going back some releases ago that when an error occurs, you know, that it generally brings up, you know, some kind of information better than before, but now there's like an error code list in the RecurDyn help documentation. And so then you can see as you go down into analysis, post tool, anyway, you get down to this error code list, and then it's a whole big table of, I think there's like several hundred error codes. And so then there's an explanation for each one. And so sometimes when the error occurs, you know, you'll also get some text information in the message window, but the description in the documentation tends to be a little bit more detailed. So I think that's a great step forward.
Is there any work going on to not just list the error code with the text, but lead to some troubleshooting help for that?
Well, that would be great. I mean, now that now that we have this error code list in the documentation, you know, if as time allows, from our side, from the motion port point of view, we are going to go over this new error code list, and then where we think that we can, you know, I mean, what's there I think is fine. It's a great starting point. But on some of these, you know, if we see that we can add more explanation, and then, like you say, add more specific troubleshooting advice in it, then what we'll do is, you know, we'll go through, create a modified table, and then just send that back to Function Bay, and I'm sure they're happy to add in those details. So that'll help, I think, to some extent.
And it might be a very, I mean, if you could get any statistics on these, it would probably Pareto out to where some small subset of that are the ones that are occurring a lot of the time, and that, you know, that
Yes.
people need the troubleshooting help on.
Right. Yeah, and I certainly know the error message that I invoke most frequently, which is, you know, I'll be importing, you know, CAD geometry, you know, doing some kind of work for somebody, and somehow a zero mass body will slip in there. So anytime you have zero mass properties, then you'll get the error message with the singular matrix and so forth. So, you know, in that case, I'll take a look at what they've put in there, and then, yeah, I have plenty of practice, so I can make a lot of comments about what to do about that. But yeah, out of the 200 error messages, many of them have to do with kind of specialty things that are done in, you know, with certain modules and so forth. So they will be, those will be occurring less often than some of the mainstream ones. You know, and if you're, by the way, if you're running into, you know, anybody that's running into frequent errors, you know, as far as like lack of convergence and so forth, one of the things we did on one of our research projects was that we monitored, you know, this was actually with ProcessNet, we could actually monitor what was going on during a simulation. And then if we saw anything going on, so in this case, we were monitoring like contact penetration. And this was in a case where we didn't know in advance kind of what was a good contact value to use, and we didn't want to set it to be really stiff because then the simulation gets to be really long and may get some vibrational effects. So, you know, we usually try to relax the contact stiffness as much as possible, but clearly to have too much penetration is not acceptable. So actually in ProcessNet, we could monitor penetration and then automatically go back and rerun with you know, a higher stiffness if needed, and then we would continue to do that until we had the penetration down to a low enough value to be acceptable. So I'm just saying with ProcessNet, there's some things we can do to maybe address certain things, and you know, and then with ProcessNet iterating, then it's a lot faster than having to do manual iteration, and it opens up this thing of, you know, tuning up the model in an overnight run with the series of simulations, but letting ProcessNet, you know, I guess some people would say, oh, this is artificial intelligence. Well, I don't know, but it's building in a little bit of intelligence into the algorithm, the ProcessNet algorithm to, you know, make adjustments to the different parameters until the model behavior is within acceptable ranges. So now we have, there's, you know, there's like too many things to go into detail. So these are ones that we can just briefly mention. So basically, there's this new capability to output the mass stiffness and damping matrix. And then this rigid RFlex system. So this is all related to doing the eigenanalysis, and so then there's a state matrix that's created and so forth. Anyway, all this can be output to this .m file for use with Simulink. Because Simulink uses these .m files. And then another enhancement, maybe not a big deal, but still helpful, is that actually the message file now has a starting time and date printed right within it when starting the simulation, so you can keep track, especially if you're doing many runs overnight, then you can see when each run started. These different commands to change the view of the graphics window in RecurDyn. So all the ones listed here are now available while an animation is playing. So in the past, you could pan and rotate, but now you can do the zooming and rotating with the point and all that stuff while the animation is playing, which can be very helpful, I think. This next one has to do with full flex, and actually I think it'll probably be covered a little bit more when that's discussed later today. But it's this offset edge imprint. So basically, imprint is all about providing input information to create a finite element mesh within RecurDyn. And so when you imprint, you want to make sure that that you have nodes along, in this case, the edge, and you want things to match. So this imprinting an edge with an offset value, into another solid and so forth. So again, I think you'll see some of these capabilities in use in the later section. And this one's just a copy paste error. Let's go down to 321, sort by type. You can arrange entities in the database window to sort by entity types. And then there's an option file that you can use, set number of threads, and whether or not to create this animation file when you're using the standalone solver. So you can read more about that if you're using standalone solver, in the documentation for the standalone solver. But I don't know how many people are using the standalone solver, but it's can be quite useful to run jobs, control with the batch file. So if you don't want to have the RecurDyn GUI up while you're doing a series of runs, you can certainly do it separately with the standalone solver. Okay, other new functions. So there's a pre-analysis that's run for each job in RecurDyn. It just happens automatically. You probably don't notice it, but you have a different option when if the current pre-analysis isn't setting things up right. We have this new thing that produces improved results in certain situations. So the view status of a body or subsystem is maintained when you go into the body edit mode or subsystem mode. In other words, when it says view status, what we're talking about here is the view that you're seeing. In the past, every time you switched between sort of levels in the hierarchical tree in RecurDyn, in other words, went between main level and the subsystem, main level, body edit, or whatever, I would always do this auto zoom or auto fit, and you can actually turn that auto fit off, and then it won't keep changing things on you. So that's just another option under display settings. So you can just go there and you'll easily see where that option is now present. When you're trying to navigate to select a point, you can now select the center of a sphere. That was not available before. You can open a utility folder, and that ability is now on the ribbon. Examples included for the Linux solver for how to use the user subroutines. There's a new C motion expression. So if you have a C motion that's driving, a certain degree of freedom, you can now reference it from an expression and use that to define some other things. A shortcut Shift plus the letter I will exit the edit modes or subsystem modes. If you're ever using the DOE, which we call Design Study in RecurDyn, you know that there's been a button to export a result sheet, meaning it would export the parametric values and all the performance indices, to what used to be, it would just be a text file. But now there's an option to also export it as a CSV file. So just make it a little bit easier to bring it to Excel. So now we're going to talk about some new ProcessNet capability. So frequency response analysis is now supported in ProcessNet. So I don't know if many people have used it, but frequency response analysis is where you're sweeping through a range of frequencies, and you generally use it in conjunction with having flexible bodies, and especially the full flex body, and then it will show you the response of the system. Anyway, so you can now control things for that with ProcessNet. And then you can export geometry to a parasolid file directly from the script in ProcessNet. So that could be supporting some overall process. And then you have this clone body change library is now added in the install directory. So under bin add-in folder. So the idea, the clone bodies are what's used in these different toolkits to represent, chain links, belt segments, track links or track shoes. And with this library, you can change clone bodies to general bodies. And by the way, sometimes this is done for, having those general bodies being able to interact with the fluids or the particles. And actually with the interfaces to the DEM and the CFD software, you can actually do that automatically. But in some cases, you may want to do that in a more selective way, so that's why we provide this library for you in ProcessNet. And then ProcessNet Helper is added into the RecurDyn help, and so then you can help search and find ProcessNet functions. You can set normal direction of a linear guide, 2D linear guide in the belt toolkit. So this is for the 2D belt, which is more recent than some of the other toolkits. So this is just an added capability for that. You can also set layer numbers for full flex and RFlex bodies with ProcessNet, and then new capabilities, set colors and different things related mainly to full flex bodies, so colors of node sets, element sets, patch sets, line sets. And then different property, property component, element component. So, in the display command when editing a full flex body, you can display only a portion of the full flex body based upon these items in this list. And sometimes it's helpful to set the different node sets or element sets different colors. So again, ProcessNet can now do that. So some additional things, you can set what the reference coordinate system is when you're importing an RFI file. That's for a RFlex body. So in ProcessNet, when you bring in the new RFI file, you can set what that new reference frame is. You can set the text information for the parametric points, which the text information hasn't always been there, but it's been there probably for the last 4 or 5 releases. But now you can set it with ProcessNet. So you have MTT3D. It has a tension sensor, and so now you can create that with ProcessNet. So you can define the location of the tension sensor, the sense density, and the range, all from ProcessNet. Patch set, auto adjust for the normal directions of the patches, and then normal directions for a line set. Similar things, all for full flex bodies. You can, for these parametric value connectors, you can grab the information. You know, I don't know if people are using these very much, but you know, in the interactive graphical interface, you can see all these different attributes. And so anyway, now they're all controllable by ProcessNet. And then tension sensor can be created for the chains. Let's see. You can delete our plot file from the database window of the plotting window from ProcessNet. You can create a plan output with arguments function. So as you can see, over time, we keep adding more and more to ProcessNet. So, and then some upgraded functions, namespaces are included in ProcessNet examples, and there's new beam belt updating the geometry information function. So now let's also look at eTemplate. So eTemplate kind of follows hand in hand with ProcessNet to some extent, but it's continually being enhanced as well. So Simulink interface functions are added, and also, you know, it's a general co-simulation with Simulink interface. Next one is RFI file can be imported with eTemplate to define an RFlex body. So in your Excel spreadsheet, you can just reference that RFI file and then process it. You can specify these different integrators, advanced hybrid and hybrid. You can use parametric values in the simulation settings. So we've, you know, like for setting the end time of simulation, things like that. And so there is the ability to run eTemplate with the eTemplate auto run program. And so you can now set it to be auto running, you know, within a certain subsystem name. So that has to be set in the template file. Oops. And then, you know, problem was fixed when you import an RFI file. If the file path was kind of a local path, then it wasn't imported, but that's been fixed now. So that's the template enhancements.
Hello, Brant.
Yes.
I have a question. If we can go back to previous slide.
Okay.
So under new functions, RFI file can be imported to define RFlex body. Does that mean that we can use the eTemplate format to create an RFI file? Or
yeah, not that I know of. So the eTemplate would just be able to read the RFI file once it's created.
okay.
Yeah. Yeah, the RFI file creation is still separate from eTemplate as far as I know.
Okay, thank you.